We have 5 bits for the block. And how many bits do we need for the tag? It will be the rest. Okay, so the total is 20. 5 are used for the block and 4 are used for the word. Okay, so the tag field will be with 20 minus 5 minus 4, 20 minus 9, which is 11. So here we'll find 11 bits for the tag. Okay, so we have 5 bits for the word, 4 bits for the word, 5 bits for the block, and 11 bits for the tag. So this is the answer for the question B. Now let's see the question C. So to which cache block will the memory 0DB63 maps? So here the address that we need is this one. Okay, so this is an address, and this address is written onto 20-bit because we have 1, 2, 3, 4, 5 digits, and each digit in the hexadecimal base is written onto 4 bits. Okay, so this is our address. We need the block, okay, to which this memory map. Okay, so to answer this question, we have to write this address using this format. Okay, so we have to write 3 on 4 bits. Okay, the first element is 3. 3 is 1, 1, 1, 0. Okay, after that we have the value 6. How to write 6? 6 is 4 plus 2, so 6 is 0, 1, 1, 0. After that we have B. B is 11, so 11 is 1 plus 2 plus 8, so it will be 1, and you have another one, we have 0, 1, and so on. Now what is the block? Okay, so to which cache block will the memory reference, this reference map? So this address is using this block number. Okay, so here we have the block number, which is 01101. Okay, so we have 1, 2, 4, 8, 16. So this value is 16 plus 4 plus 2. 16 plus 4 is 20. 20 plus 2 is 22. That means this address, okay, is mapped in the block number 22 in the cache memory. Okay, so we'll find this address in the block number 22. Okay, so here the block number 22 in the cache. Is this clear? Do you have any question about this? Okay, Mariam, question B. I will repeat it. So question B is, what is the format of the memory address as seen by the cache? That means if you have this question, that means we need the size of the tag, the size of the block, the size of the word fields. Because in direct mapping scheme we have 3 fields. We have the tag, we have the block, and we have the words. Okay, so in this example we have this scheme. Okay, so we have 32 blocks in the cache, and we have 16 words per block. We have 2 to the power of 20 words in the main memory, and we have 16 words per block. Okay, so to find the number of bits of the first field, which is the word, we have to know the number of words do we have per block. So how many words do we have per block? We have 16 words. Okay, since we have 16 words per block, okay, that means we have, so 16 is 2 to the power of 4, that means we need 4 bits to select one of these words. Okay, so the field or the word field is divided into 4 bits. Why 4 bits? Because we have 16 words per block. And how many bits do we need to select one of these 16? We need 4 bits. And same thing for the block. How many block do we have? We have 32 block in the cache. So here we have 32 block, okay? And to select one of these 32, how many bits do we need? So 32 is 2 to the power of 5. That means we need 5 bits to select one of these 32 blocks. That means here we have 5 bits in the block field. And for the tag, we have to take the rest of the bits. So the total number of bits is 20. Why the total number is 20? Because the total number of addresses is 2 to the power of 20 address. We have 2 to the power of 20 words. Okay? So how many bits do we need to select one of these words? We need 20 bits. That means here the total number of bits is 20. How many bits do we need for the tag? We have 20 minus 5 minus 4. 5 plus 4 is 9. 20 minus 9 is 11. Is it clear now? Very good. Do you have any question, Mariam? Okay, welcome. Let's continue. Okay, so now we have done with the cache mapping scheme, which is the first one of mapping scheme, which is the direct mapping scheme. Okay, if we summarize, so the direct mapped cache maps the main memory block in modular fashion to the cache block. Okay, the mapping depends on the number of bits in the main memory address, because we have to extract the number of, we need to know the total number of bits of the main memory address. Okay, and it depends also on the number of blocks that we have in the cache, which determine the size of the block fields. And we have to know also how many address do we have per block, or how many byte per block, or how many word per block, and this determine the size of the word field. So we can call it word field or offset fields. Okay, so the direct mapped cache is not expensive, so it's not very expensive. It's not as expensive as other caches, because the mapping scheme doesn't require any searching, because we know the relation between the address in the cache memory. The relation between the address in the cache memory and the address in the main memory is modular relation. So y equals x mod 10. Okay, that means if the microprocessor needs a value at the address 25, the microprocessor knows that this address can be in the cache memory at the address 5. So no need for search for it. It can go directly to this block. Okay, so each main memory block has a specific location to which it maps in the cache. The main memory address is converted to the cache address. The block fields identify one unique cache block, and the CPU knows a priori a cache block number, because there is a relation between the address in the cache memory and the address in the main memory, which is y equals x mod n. So this is for the direct mapping scheme. So now we'll start the fully associative mapping scheme. Okay, but we will take just 10 minutes for the prayer and we'll return back.